right, what's up everyone? We are live. It is Thursday. We are solving some Leetcode problems. Welcome. Let me just get this, let me just share this link here and we will get right into it. If you're joining for the first time, as we do on these streams always, what I'm going to be doing is solving one of the recent Leetcode contests. So I'm going to be going through some of the I'm going to be going through the problems, I'm going to be taking you through my thought process, and that's what we're going to be doing. I'm going to be showing you how to approach problems that you've never seen before so that you have a better understanding when you're in your interview of what does this process look like when I see a problem that I haven't seen before. How do I come up with a solution when I don't know what to do? Because we end up in this case a lot of times, if you've come to these streams before, there have definitely been times where I'm like, I don't know how to solve this problem. But the whole point is that we're going to figure out how to solve the problem, right? We're going to work through it together. We're going to work through to a solution, and that's what we're doing here. What's up, Kevin? Kevin says, first time here, glad you're here. And let me just share this real quick. And grab the Leetcode link here. So we're doing contest number 281, okay? Yeah, 281. I'm gonna share my screen. Apparently this contest was unrated because there was, I wonder if this got affected by all these outages the other day. All right, so here's our contest. What we are doing is just gonna go jump into these problems and work through some of them and see how quickly we can come up with some solutions. So let's go ahead and just jump right in. And if anyone has any questions as we're going through this, go ahead and put those in the chat. Happy to answer some questions in between these problems here and help out however I can. So let me also put my, hold on. Let me stop sharing this. I'm gonna make sure that I have all these notifications turned off. All right, that way we're not going to be bothered here, and let's get back to it. All right, so for this first problem, given a positive integer num, return the number of positive integers less than or equal to num whose digit sums are even. The digit sum of a positive integer is the sum of all the digits. Okay. So, in this case, if num is 4, then the only possibilities are 2 and 4. If num is 30, then we have all of these different possibilities. Right? We have 2, 4, 6, 8, 11, 13, etc. And now, I think the easiest way to do this, and this is true with most of these problems, is going to be to simulate everything. So like, just looking at this, our number goes up to 1,000. Right? That means that our number is never going to be very big. And so we could literally iterate through all possible numbers from 1 to whatever our number is and just check whether all the digits are sum up to an even number or not. Right? That's going to be our easiest approach. But that is not necessarily going to be our most efficient approach here. So in a problem like this, again, simulating it, that's going to be our easiest solution. But I am thinking that we might be able to get a little bit more clever with it. For example, if we're only looking at numbers from 1 to 1,000, then we could actually, for example, pre-compute all the values from all the counts from 1 to 1,000 and make an array, and then just look up in that array. Right? We could also, so this would be great if we were, for example, computing it multiple times. We could also hypothetically, you could just enumerate all these possibilities in a big array in your code. Like if we wanted to come up with a really fast solution, the fastest solution we could probably come up with would be to come up with a 1,000 length array. So we would basically have some array, and it would just be like, it would just be the count for each one. So for 0, the count would be 0. For 1, the count would be 0. For 2, the count would be 1. For 3, the count would be 1. For 4, the count would be wow, this is just confusing me already. 2, etc., etc. And basically, for each one, for each value, it's either going to be equal to if all the digits are even, it's equal to the previous one plus 1. And if all the digits are odd, or if the sum of the digits is not even, then it would just be the same as the previous one, right? So we could generate all this, and then if we were calling this multiple times, we could either just say, in our code, all counts equals this, or we could write some code that would calculate this first, and then return our, and then look it up in this table, right? So this is something where if we had all those values, we basically end up with like if we had just some long array in here, then it would just be a constant time lookup, and so we'd have a very efficient solution. So we would have, there would be constant time, and technically it's going to be constant space too, because the numbers only go up to 100. We have a fixed size array, right? And it's not changing. So that would actually be a very theoretically efficient solution. I'm not going to do that because I don't want to compute this whole array. But the other things that we could do is think about, is there a more clever approach? And when I think about, is there a more clever approach, my immediate thought is that what is it that defines a number being even, or like the sum of the digits being even or odd? Basically, what we're asking is either are all the digits even, or are there an even number of odd digits? Right? If there's an even number of odd digits, then the odd digits cancel out and become even. And if there are any even digits, those don't affect the evenness of the solution, right? Or of the count. And so hypothetically, what do we have? We could say for a given number that what are all the numbers that only have even digits? How many numbers are there that only have even digits? And then how many numbers are there that only have an even number of odd digits? And I think that we might actually be able to compute this for an arbitrary number. And let me think about this for a second. So let's say that we have a number like our number equals 495. Now, there are basically, we have two possibilities. Either the first number, for each number, they can either be even or odd. And then let's consider what are the number of possibilities where all of the digits are even. Well, so we could have the first digit could be 2 or 4, so there's 2 possibilities for the first digit. Then the second digit could be 0, 2, 4, 6, or 8. So there are 5 possibilities for the second digit. And then the last digit could also be could be 0, 2, or 4. Actually, no, it could be anything, right? So we would basically get times 5, right? Both of those digits could be anything. And this would essentially give us all the numbers with all even digits that are less than, what was it, 499. Would basically then give us, 50, right? So it would be 2, 4, 6, 8, 12, and then I guess you skip all the 10s, and then you have et cetera, et cetera. So there would be 50 numbers there, and then the question becomes, how many are there with, well, one, we would have to remove all of we're only going up to 495, so we would have to consider, I guess we only really have to consider the ones place here, but it's like, this would get a little bit complicated, because if this was 465, then you end up with, we might be able to make this work. I'm not sure, thinking about this now, whether this is going to be easy enough to come up with on the fly that I really want to even try. Because the question then becomes, okay, well, how many numbers are there that have exactly 2 odd digits in them? And because there can either be, given that this number is 3 digits, we have to have exactly 2 odd values. And so you would end up with, you have to decide basically, is the first value odd or even, and then it gets a little complicated. So let's just, for simplicity's sake here, we've talked through a couple examples. I honestly don't see a real reason here to optimize to super optimize this. It's like, I think that the easiest, at least for starters, is just going to be, because like the most optimal solution is just going to be to pre-calculate everything and then just look it up. Is that a boring solution? Yes, but it is the most optimal solution. And so my feeling with this is that since the most optimal solution is so boring, I don't even really want to implement it. Let's just implement the normal solution instead. So we're going to say, and then I'm just going to implement some, helper function. And basically we're just going to say while num is greater than 0, sum plus equals, if it's sum plus equals num mod 10 is going to get us that smallest digit, and then sum divided by, num divided by equals 10, and then we just say return sum mod 2 equals 0, right? Like we're just saying, is it even or not? And then all we do here is we'll keep another count. And then we just say if even but we're just going to count if it's even, and then we'll return the count. So I mean, like, this is very simple. We are doing less than or equal to. Okay, that's my bad. Where are we at? We're off somewhere here. So the input was 4. Oh, and this is supposed to start at 1, right? Yeah, okay. Alright, so we're kind of right in the middle here, runtime wise, space wise, we're also kind of right in the middle. Again, this is a very simple solution. I think that I'm trying to think just like what we could potentially do to make this faster. So okay, like some things that we could do would be to one making this function call is going to slow us down, right? In terms of the actual execution of our code, it's going to slow us down because function calls just take time. There's overhead for making function calls. So one simple thing that we could do would be to, if we want to make this faster, like let's just see how this compares, because now I'm curious. As if you've come to these streams before, you know that this is kind of this is where I always get curious about, like, how do we improve things. So in this case, we'll say, and then what really this becomes is just this goes in here, right? And this, I mean, it doesn't actually matter. We can count that out. I think this is. Alright, so. Oh yeah, I guess I can't. I need to. one, this should be I, and two, I can't update I, so I'll do current like that. I think that should. Okay. So in terms of the runtime, we're looking basically exactly the same. So this is interesting because that didn't, we don't really know. Obviously, it's running very fast regardless. It doesn't seem like that really had any impact on our actual runtime. So what else could we do? I think the other things that we could do are, for example, what we might even do is like, we could even subdivide this or do other things where it's like maybe we don't want to compute the values for every possible one, but we could compute like, starting in the middle. Let's actually, I'm curious, like let's actually see what happens. So if we, I want to go back to this previous solution because it's just simpler. I wanna go for the I wanna try the hacky solution and of just initializing all of these and seeing what happens. So what we really need to do is we first need to compute this array, and to do that we will so what I'm going to do is I'm going to initialize this is like awkward. I prefer to just write a script for this rather than try and fit this into what we have here, but it's all I'm going to do is I'm just going to say I guess the largest value could be 1,000, right? So we're just gonna say val I equals alright, so is it not going to give us the, if it doesn't give us the whole output, that's annoying though. Because then I have to run it like on my machine. How many does it actually give us here? Let's because we could just create a quick thing here. Drop it in this. Nope, that's not it. All right, and then if we run it, gonna stop sharing my screen for a sec to make sure that like you don't all hack my computer or anything. All I'm gonna do is just run this though. Alright. Hold on. It's like, of course it's really annoying to try and actually copy this Leetcode template and run it because there's all these like little things that make your life difficult. So it's just taking me slightly longer than I had hoped, but I have this list now. So let's go back to our, share my screen again. Alright, so I've generated the whole list. The whole list just looks like, let me just, I can just delete all this. Looks like this. So we end up basically with this, and then we just return vals none, I believe. Yeah. Alright. So, I mean, this is a hacky solution, but it does work, and you can see like obviously this runs pretty fast in terms of our total solutions. We are using more space in this case, but you know, this is one of those interesting like experiments, right? Where again, I'm just kind of curious to see what happens in this case. I wonder, like, we might even be able to, you know, again, maybe we even come up with some like, I still think there might be a way for us to just directly compute the value as well based on like the number of even and odd digits, but like, you know, it's all an experiment. Alright, let's move on to something a little more interesting. Hopefully. Alright, so in this case, we're given the head of a linked list which contains a series of integers separated by zeros, and the beginning and the end of the linked list will have value 0. For every 2 consecutive zeros, merge all the nodes lying in between them into a single node whose value is the sum of all the merged nodes. The modified list should not contain any zeros. Okay, so I think, let's get clear here on what we're doing. So basically what's happening is that the zeros become these dividers, and we're summing up the sub lists between the zeros, right? So we're going to sum up this, and we're going to sum up this, and we're going to get 4 and 11. In this case, we're going to sum up 1, we're going to sum up 3, we're going to sum up 2 and 2, and so we're going to get 1, 3, and 4. Okay. And the first and last nodes are going are going to be 0. That makes our lives easy on that front. And then, yeah, so I mean, honestly, this seems like one of these things that I'm not sure that we're going to have to iterate over the entire list either way, right? No matter what we do, we're going to have to iterate over the entire list. So it's going to take us all of n time best case scenario, right? There's no way that we do this in less than O of n time. And the simplest solution seems to be that we basically just compute running sums and add them onto our linked list. So I'm not sure that there's a whole lot for us to do other than just implement. We're gonna say, when we see a 0, I basically take my running sum, I add it as a new node onto my result list, and then I start my count over again, and I just repeat that process. And so, with that, what I might do is we'll have a, let's see. And let's see just some edge cases here. So, okay, there are no two consecutive nodes that are 0. Beginning and end are 0. And I don't think we could probably, it seems like we could have a list that is just a 0 and nothing else, which would just be an empty list, I guess. I'm not totally sure on that one. We'll have to see from the test cases, honestly. But essentially, we want to, iterate through this whole list. So we'll have, let's see here. So while head is not null, what's going to happen, right? If we're going to have some sum, and then if head.val equals 0, then we're going to add the sum to our result list. And so what I'm going to do is I'm going to say that we and I'm going to say, let's go ahead and just initialize this with like a dummy node, and then we'll like a dummy head, and then we'll just start at our first node will be head.next. So I'll go ahead and say, let's say if head is equal to null, we'll just return null. Otherwise, the head is going to be new list node, and we'll initialize it to be 0, although I guess we don't actually have to initialize the value at all. So, and then the sum is 0. So we'll go ahead, and then we'll go ahead and, I guess we can't actually call this head. And then we'll call, and then we also need our list node cur is going to be equal to dummy head. Now we'll, lastly, okay, our head, I'm going to go ahead and say head is equal to head.next, which is going to be our first value. And then here's what I'm going to do. So if head.value equals 0, then I'm going to add the sum. So I'm going to say cur.next equals new list node sum equals 0, and then otherwise, and cur equals cur.next. Otherwise, sum, sorry guys, plus equals the value of the node, right? So head dot val. Yeah, and then we're going to return dummy head dot next, right? So that's going to be the beginning of our actual list. Let's test this. Something. I'm not incrementing my head. That would be a major issue, right? So head equals head dot next. All right, so that worked. Let's try it, and we're all good. All right, so we're sitting right in the middle here. We're sitting. I'm curious about this over here. These like solutions that are using a lot less space. My guess, so I mean, obviously this works fine. My guess is that if people are using a lot less space, it's probably because they are modifying the original list rather than creating a new list. Otherwise, you know, most of the memory allocation is just going to be like there's not really much to do differently memory wise. I think, you know, when you're looking at this, the other thing to look at is where with basically everything in this range here, this entire, like, okay, this says I beat 46% of the job submissions, right? But like, what's really the difference between, you know, 46 and 50%? And the answer, the short answer is nothing other than that it probably just ran differently one time than another. Like, this is one of these things where most of the time with our code, it doesn't actually, there's enough variation in the way that it runs that we're not going to be able to just say it uses exactly this amount of memory every time. Like, you could run it 2 different times and see different time, different space complexity, because that's based on, you know, I'm not actually sure how Leetcode is calculating that, but that's based on, you know, machine level factors. And so, you know, that could be affected by like the operating system and how it's allocating memory. There's things that can happen there that, you know, significantly change how that works. So like looking at, like, let's look at this example. So we have our, you know, this is basically what we did, the head value, then head equals head.next. So this is basically doing the same thing that we're doing. I'm not really sure. I'd have to, it's hard for me to compare the code samples. Like, there might be something that's slightly more efficient here, but like effectively this is the same solution. I actually have no idea why this is using so much less memory. I'm kind of curious now, but I'll look at that later. Let's do one more problem. All right, construct a string with repeat limit. So we're given a string s and an integer repeat limit. Construct a new string repeat limited string using the characters of s such that no letter appears more than repeat limit times in a row. You don't have to use all the characters from s. Return the lexicographically largest repeat limited string possible. So string is lexicographically larger if the first position where A and B differ, the string A has a letter that appears later in the alphabet. Yeah, so basically, I mean, lexicographically larger means that it's like the latest occurring in the alphabet, which is kind of like basically sorting them backwards. And then otherwise it's the long. If they're otherwise the same, then it's the longest one. So okay, repeat limit is 3 here. So we're we have our letters C, C, Z, A, Z, C, C, and then Z, C, 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 A, C, C. Okay, so really, and then we use all the characters. All right. In this case, yeah. So in this case, we're not using all the characters. I was trying to think, why would we not use all the characters? And the only reason to not use all the characters is because it is causing us to, have a longer repeat. And essentially, you know, this is something where this comes back to what we've talked about on some previous calls, where it's like, essentially one way to do this would be to try every possible string, right? We could generate every possible string that fits these constraints and doesn't have more than the however many repeated characters. We could sort them all and figure out which one is lexicographically the largest, right? That would be kind of the simplest way for us to figure out what that string is. Now, obviously, that's not going to be a very efficient solution because there are lots of possibilities, and as we've talked about in the last couple of weeks, when I see this pattern of, okay, we could try finding all the possibilities, my immediate thought is, can we use dynamic programming or can we use a greedy approach? Because if we could use one of those, that's going to be a lot more efficient. And now, as I'm thinking through it, I want to see if we can come up with a greedy approach first, because if there's a greedy approach, that's going to be simpler than coming up with a dynamic programming solution for sure. And it's also likely to still be faster than a dynamic programming solution and use less space, because with dynamic programming, we're going to have to store everything into our array. There's going to be lots of stuff there. So in a problem like this, I think that there's a greedy algorithm that pretty immediately comes to mind for me, which is basically, we want to figure out the string that comes latest in the alphabet, essentially. And so if we have a list of characters that are available to us, then essentially we can just pick what is the latest character in the alphabet that we still have available, and that doesn't violate our premise. So we're basically saying, I'm starting to construct a string, and I have characters to choose from. I always want to choose the last character in the alphabet that I can. And then as I start building my string, the only time when I wouldn't choose that last character in the alphabet is because I have already repeated however many of that character in a row, and so I can't add another one. So what I would do is I would choose the next last character in the alphabet, and then after that I repeat, where I say, okay, I'm going to pick the latest character in the alphabet I can, might be that same character, might be a different character, and then I keep building out the string that way until I've either used all the characters or I can no longer do this. And so that's what I'm thinking. I'm pretty confident that there's, just thinking about, like, with the greedy algorithms, I want to think about, is there a case in which this wouldn't work? Because that's kind of the concern with greedy algorithms. And honestly, in a case like this, we're always going to want to favor the last letter that we can. So I'm pretty confident that just, thinking through it for a second logically, I can't see a way in which this wouldn't work. We could spend some more time looking for examples, but I feel pretty good about that as an approach. And like, if we look at this example, I think it should work for this. So like in this case, we're going to say, okay, let me pick ZZ first. Then I'm going to pick CCC. Now I have 3 C's in a row, so I have to pick A. And then I pick C, and I've used all the letters. So I feel pretty good about this. Now the one question is, how are we going to store all of our letters? And we really need to store letters and counts. And we're going to need to be able to access them in order of what is the last letter. And so I'm kind of thinking that we might want to do 2 things. Because what we really want to do is we want to be able to do 2 things. One is we want to be able to access the letter that comes the latest in the alphabet. And 2, we want to be able to know how many of those letters that we have to work with. Right? And so what we could do is, and we're always either going to need the first letter or the last letter or the second to last letter of the remaining letters. So like, I'm almost thinking, so one possibility would be to basically create a list and then add stuff into the list in reverse order, where we would basically have a list of pairs or of tuples that would include both that value and the letter and the value. Another possibility is we could use something like a map, but the downside of using a map is going to be that we're not maintaining the keys in sorted order, right? And so if we want to figure out what is the last letter that we have to choose from, then that is a little bit harder. Another possibility is that we could keep an array of the characters and then also, or we could keep a list of the characters and then also have another something that we're like referencing with those in it as well. And so I'm thinking like maybe the easiest would be, and all of this is kind of redundant anyway because our, like, technically I don't really need to worry about any of this. The easiest would just be to use an array of length 26 or whatever, and then use an array of length 26 and then just store the counts. And then every time I need to look up a letter, I'm just going to scan from left to right. Like that would be the easiest. But but like it doesn't actually matter because it's going to take, like, because there's a fixed number of letters, all those scans are technically constant time, so it wouldn't affect our complexity. What I think is going to be easiest though is let's do two things. Let's keep a set of all the letters that we have available, and let's also keep that array. So what I'll do is I'll have a set of and then I'll have an integer array, and it's going to be a length 26. Now, the first thing that we need to do is basically fill out both of these, and so we do that by, we're going to iterate over our string s. So for and this is fine, we don't need to double check because it's just going to, the set's going to deduplicate anyway, and then, so we'll have this. And now I'm forgetting why I wanted to do the set in the first place. Yeah, actually, I take it back. I don't know that we really want to do the set because what we really need is, again, we need the letters in like order, and the set's not going to actually help us with that. Like we could hypothetically do, I guess really what we want to do is like a priority queue. Honestly, is like something that's gonna track everything in order, but then that's not like, it's not really great for what we're doing here because we don't really want to it's going to be like with a priority queue, it's going to be hard for us to duplicate stuff. Honestly, I'm going to skip the set entirely for now. If we want to figure out like how can we make this more efficient, that's something that we can consider in the, as a update. But basically here, C minus A is going to take they're all lowercase characters. So C minus A converts our character into the index where A is 0, B is 1, C is 2, etc. Plus plus. So that's going to give us our array initially. And then really, okay, so what I'm going to do is I'm going to say, I'll create a string builder. And then we'll have an int number of repeats equals 0, and we'll have and then essentially what I'm going to do is say, yeah, we're essentially iterating over this array over and over again. This is like kind of awkward. Like I'm trying to think if there's a better way to do this. Because what we really want is, what I want to know is basically what are the letters that I have available in order, and what are the counts of all of them. So like, what we could do is we could do this as yeah, maybe what we want to do is have like a list. Like we could keep a list. So then this becomes basically, right, only if we don't already have that character. We're gonna say all cars dot add C, and then this, and then what we do is we just sort this, right? So I believe that is just, and I think we can do let's do an array list here, just because we're going to be referencing multiple indices. So we'll say while, and I'm basically going to remove the characters from this list as I go. So while not all chars dot is empty, so what we'll first do is we'll say if num repeats equals, I guess actually we have one other option, right? So if num repeats equals repeat limit, and there's only one character left in the array, right? This is kind of the one case in which we can't use all of our letters. So and all chars dot size is equal to 1, then we break, because we can't use all the letters. Otherwise, if num repeats equals repeat limit, then all what we do is we take the second character in our array, right? Essentially. So we'll say num repeats, well, sb dot append all chars dot get 1, and then we've now added a character, so char counts we should really just do this. We'll append that to our string. We're going to decrement it by 1, And then if it's equal to 0, then we remove it from our list. And what else do we need to do? Now we also need to update, so num repeats equals 1 and repeated char equals to add, right? Basically like that. Now otherwise, we're gonna just add the first, if we're not at the repeat limit, then we just add the first one. So to add equals all chars, I get 0, and then it's basically the same thing. So this becomes 0, and num and then we say if to add equals repeated char, then num repeats plus plus and else num repeats equals 1 and repeated char equals to add. The end, we return our sb.to string. And I think that's it. So let's see if this, let's see. Why is that a boolean? Probably. Because two is it, I think it's saying that. Oh, okay. It's the whole thing. It cannot be converted to boolean. So if this is equal to 0, right? Okay. I was like missing the thing that was right under my nose. And this, I misspelled something, right? Repeated. Alright, so in this case we did get the correct answer. So why do you... Okay, so why are we... This is odd, because this is very similar, right? But it's just like slightly different. So let's see what's going on here, because I'm very curious actually. So the whole output the whole time. So that's not the way. All right, so let's start with what we're actually ending up with here. So let's try this. Okay, so we have 1A, we have, what's the actual string? We have B and B, we have 1C. I mean, I'm kind of assuming this is correct. I don't, it's gonna be way too much of a pain to actually go through and validate all those, and I don't see any reason, like, it doesn't look obviously wrong. So I'm fine with that so far. Now let's see what we're working with. Oh, okay, so I think that, well, so let's check here, basically, let's print out what we're working with. So, speed string. We'll also print out the number of repeats and the repeated character. So we only had, I should have left this in before because it's actually going to be helpful for us to see. Let's print out, actually I'll print it in here. Alright, so initially we get, what does that matter? Oh, it's the number of repeats, right? And we can have max 2. So in this case, we add the y and we add what's repeated once. Now we get the next one, it's the x, and we have 2 of those, right? So we add the x, it's repeated once. Now we add an x again, it's repeated twice. And so now what we should be taking is the v, but we're getting that we have that repeated character, so we need to just add, this is if we're at the limit and the repeated character is, and it's equal, right? So it's, right, like that's basically, I believe, the issue here. So if we run this again, we should end up with yxx vvu vus rr qq pp. Okay, so we're basically, it looks like we're right until the very end, and then we should have included an A at the end, which we didn't, and why we didn't. Yeah, so we should really, I mean, I think that this is kind of shooting us up in the foot a little bit by having this first, because it's really, we're getting these repeats and then we're breaking before we should. we might be better off just saying, like, if I just reorder this a little bit, I'm gonna basically say, so my first possibility is that if num-repeats is less than repeat limit, or oops, no. Or the current character is not equal to this, then we can just do the normal thing, right? Like maybe that's a better way to do it. So we'll do this. Otherwise, it basically becomes if this, then break, and otherwise. Like it becomes this, and then this is, and I'll add these so that it's consistent, else do this. But I'm just changing like the ordering to make sure that we're like getting everything correct, and I think that should, yeah, that looks right. Perfect. So let's try this now. Perfect. Yeah, so that was a little awkward. I mean, there's a bunch of stuff going on, but alright, so reasonably efficient solution, time and space, I'm happy with both of those. I think the big thing here was just, what's annoying with this problem is that we have these two different things that we kind of need to keep in parallel with each other, right? We need to keep in parallel both the, we need to keep the order of the letters, and then we also need to keep the counts. Now, one thing that we could have done here that I think might have been slightly easier, but I just, it's a little bit easier for me not to do that because my Java on that front is a little rusty, but we could have created a list of some sort of like custom, like a tuple or something. The thing that we would just have to do with that is we would have to implement some sort of custom comparator so that we could sort it based on the letter values alone. But we could have had some sort of like each element of the list was basically the letter and the count. The downside of doing that though is that it's still, I mean, you would have to kind of, the way that we would probably want to do that is you wouldn't want to generate that as you were going through initially, because you would be having to find stuff in the list, so you'd have to have a map to stuff. I mean, it gets a little awkward. It's a little similar to like a LRU cache type problem or something like that. Cool. Well, I am not going. I'm gonna call it at 3 problems today. I have a bunch of other stuff I need to work on, to be totally honest. I did see someone said failed a coding interview badly and it was demotivating. The question was easy, but I just felt so nervous. So yeah, this is one of those things where, that's gonna happen. You're gonna end up in situations like that where you fail an interview and it's not because the question was hard, it's because you just got nervous or you didn't know what to do, or it was something that you hadn't studied. And the key is just, you can't let yourself lose motivation, right? In the long run, you are going to need to keep your motivation up and realize that failure is part of the process, and failure is how you learn, right? You learn by failing, understanding what you did wrong, and then doing better the next time. So with that, thanks everyone for joining. I appreciate you all coming and hope everyone has a good rest of the day.